All right, ladies and gentlemen, clearly I'm out today, so I figured I would just leave you some notes via video. We all should have our note sheet at this point, and we all should be writing. Whoever is facilitating this video, feel free to pause and rewind if need be. All right, so today we're talking about graphing quadratics in standard form. All right, standard form is ax squared plus bx plus c. I'll tell you what that means here in just a second. So what are we learning? We're learning how to identify the a, the b, and the c of a quadratic. We're going to identify the x-intercepts. One thing to note is the x-intercepts are also known as the roots, zeros, or solutions. Okay, so if you're trying to find the zeros, same thing as x-intercept. Trying to find the roots, again, same thing as x-intercepts. And of course, solutions, same thing as x-intercepts. Okay, and then the last thing, we're going to identify the vertex when given a graph. We'll talk about how to do that in other ways later, but today we'll just find it when we're given a graph. All right, so I'm going to do an example out here to the side to show you how to find your A, B, and your C. All right, so if I had, let's say, 2x squared plus 5x plus, let's just say 10, okay? All you're doing to find your A, B, and C is you're just taking your numbers from this. So this first number would be A, and the sign as well. So there's no negative out there, so this is just a positive 2. Next, we have our B, which is just 5 in this case, and then C is 10, and it's a positive 10. So you would just write it out like so. So A, let's go with a different color ink. Got A is 2, B is 5, and C is 10. Okay, so if I had another example, let's do another one. If I had negative 2x squared plus 4x minus 12, in this case, our A would be negative 2, because again, you're taking the sign that goes with it. Our B would be 4, and our 12, and our C would be negative 12. So B is 4, and C is negative 12. Okay, so now I've given you some examples out here to the side. And so we'll go down here for our example number 1. The directions are identify A, B, and C when given a quadratic in standard form. So I'll do this first one together. All right, so look, out here, if there's no number, it's just an understood 1, okay? So right here, that would be the same thing as a 1 being out here. So in this case, A would be equal to 1. B, there's a 5 there, so obviously we're putting 5. And then C is 10. Okay. I'm going to go over the rest of these, but now would be a good time to maybe pause the video and try this next one yourself. So I'll give you a second to do that. If not, you can just keep it playing, and I'll start talking here in just a second. All right, so maybe you paused, maybe you didn't, but let's go over it. So right here, again, there's no number out there. That would be the same thing as a 1 being out here. It's not always going to be 1, but clearly in this case, it is. So A is equal to 1. Here we have a minus 6x, so we take the sign that goes with it. So B would be minus 6, or negative 6. And then C, we have -3, so that's a -3. This is pretty easy stuff, folks. Pretty easy stuff. All right, so again, you can maybe try to pause and do this next one, or you can just follow along, and this will be your notes. You'll have time to practice at some point. So, all right, so let's talk about it then. So, again, we're finding A, B, and C. All we have to do is take our numbers that are in each position. So A here, no number there, so again, we're saying that's a 1, so A is equal to 1. Then you have a 5 here in the B position, so we have 5 there. And then obviously we have a 10 there, positive 10, so 10 there. And that's how we identify our A, B, and C. This is something that you should have done first semester, so this could have been maybe a review for you. But if you didn't know what you were doing, hopefully this helped. All right, so let's go on to our next part here. Okay, so in this case, in following the directions, we're going to find our A, our B, and our C. We're going to find our x-intercepts, and we're going to locate the vertex, which is pretty easy. Okay, so first, A, B, and C is pretty easy. What we'll do is we'll just write A, B, and C, and it's right there. It's given to you right there. So again, there's no number out in front there, so we know that's a 1. And then the next one here is an 8 in the B position, so we got 8. And then lastly, we have the 15 there, which is our C. Okay, so we have A, B, and C. Now we want our x-intercept. So how do we do that? We're looking at this function here, okay? And we know that this here is the y-axis, and this here is the x-axis. So what an x-intercept is where this function here, or this line, cuts through the x-axis. And we can see there's 2 points there, one there and one here. So we can put our points there, and those are our solutions to the quadratic, or as I just said, x-intercepts. So we can say x is equal to -5 and x is equal to -3. All right. Then the last thing is finding the vertex. So the vertex is the part that's dead center of the line. We'll talk about the axis of symmetry later, but this is at the exact turn point. So it's going down, going down, going down, and it goes flat right there before it's not necessarily flat, but it starts to turn right there as it goes back up. So the turning point is your vertex. So right there is your vertex. So we'll put a point there. Okay. And for the vertex, all we have to do is find out where it is on x. So right here is x. That's -1. And on, I'm sorry, not -1. Where is that on x? So on x, it's -4. Right there. So this green point, when you go up, on x it's -4, and on y it's -1. So your vertex, you always start with your x, is -4, comma, -1. Again, it's where this point would touch on the x if you went up to it, that would be at -4, and where it touches on the y if you went over to y, -1. And so this is our vertex. And that's all we're doing, folks. So we'll do another one. Let's look at number 2. Again, we want our A, B, and C. And we're getting that from right here in the standard form. So A is 1, B is 4, and C is 3. So let's write it out. So 1, 4, and 3. Next thing we want is our x-intercepts. Okay, so where are they? X-intercepts, again, are where your function here cuts through on the x-axis. So we have one there, and we have one right there. So we'll write our points. And those are at x is equal to -3 and x is equal to -1. There's our x-intercepts. Then our last thing is our vertex. Again, it's at the turning point, so this is going down, 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 down. It's turning right there, right before it starts to go back up. That is our vertex. So let's put that down right here. Okay, so again, you get your x and your y. So if you go up where this green point is to x, that's a -2. And right over here, you go over to the y, that's a -1. So it's -2, -1. So -2, comma, -1. And that is our vertex. So let's move along to the third and fourth options. This could be an opportunity to, again, pause and try number 3 here, and then you can come back and listen to see if you got it right. Or again, you can just keep on listening to me, and we'll just keep pushing through as notes. All right. So again, we're trying to find our A, B, and our C. And again, we get that right from above there, right next to number 3. So A, B, and C are here. Remember, that's a 1 out there. This is a -6 for B. So let's write it. So 1 minus 6 is the same thing as a -6. Then out here we have a 5 in the C position. So 5. Then we want our x-intercepts. Again, it's where this function is crossing through the x. It's crossing right there, and you can see right there where it touches. So we'll draw our points there, and that's at x is equal to 1 and x is equal to 5. Last thing we're looking for is the vertex. We can see it's going down here. It stops there, and it's going to start to turn to go up. So we know that's our point right there where we're going to identify our vertex. So we'll put our green dot there. Again, we're looking for our x and our y. So we go up to x, and it's at 3. Even if you wanted to kind of help yourself by giving yourself like little dashed lines here, which we'll do that when we're talking about the axis of symmetry. So right there it goes up to 3, and over here it goes over to -4. So we know our points are 3, comma, -4. That's our vertex. All right, let's move along to number 4. Again, doing our A, B, and C. A is 1. B is 8. And C is 12. So 8 and 12. Again, we want our x-intercepts, zeros, or solutions. We can see that it's cutting through right there, and it's going to cut through right there. So we'll put our points down right here at -6 and -2. So we know x is equal to -6, x is equal to -2. Those are our 2 x-intercepts. And then the last thing is our vertex. So So we're going down. It's going to start to turn right there as we go back up. So we know that's our point right there, or our vertex rather. So let's put that on there. All right, and again, if you struggle with finding your x and y, you could do your dotted line or your dashed line again. We're going up and we see on x it's -4, and on y it's -4. So we have -4, comma, -4, and that's our vertex. Okay. So notice I'm giving you a format to use here. So you're putting your A, B, and your C straight down. You're putting your x-intercepts right there, and you're putting your vertex right there. All right. So let's move along to the last two examples. All right, on this one, I'm going to show you how to write the x-intercepts in an ordered pair. Okay, so that's pretty much close to the same thing, but I just want to make sure I show you how to write it as an ordered pair. So again, going back to what we do, writing our A, B, and our C. And we have a 1 for A, a 6 for B, and an 8 for C. So we have 1, 6, and 8. Next thing we want to do is find our x-intercepts, which are there and there. So we'll put our points right there and right there. And so before I was showing you x is equal to -4 and x is equal to -2. Okay, so to write it in an ordered pair, that's writing it in parentheses. So we already know what the x value is. You see there, and at y, it's 0. So an x-intercept always just has a 0 at y. So that would be the same thing as -4, comma 0 for that, and then -2, comma 0. So both of these are pretty much the same thing, just a way to show your x-intercepts or your solutions. Okay. Kind of the same thing we do for the vertex. Because again, when we do the vertex, we're showing the x and the y. So here, the x is at -4. It doesn't go up or down, so you just go over to see where you're at on y, and that would be 0. Okay. So let's look at the vertex now. So going down here, it's going down, it's going to turn, stops right there before it starts to go back up. So we put our point here. And then we can go up, and you see that it's at -3 for x and -1 for y. So we have -3, comma, -1 as your vertex. And that's that. So then last example here. Again, we're doing the same stuff, folks. So we're finding our A. Let's go back to red, since we've been doing that, or whatever that color is a little kind of dark for red. But A, B, and C. All right, so we got a 1 there. Again, if there's no number out in front, it's a 1. If there's no number out in front of the variable, it's a 1. So we have a 1. We got a -6 in the B slot, and then we got an 8 as your C. Now we're looking for those x-intercepts. Going here, we see we got one crossing right through the x-axis right here, and one cutting through the x-axis right there. So we'll put our points there. And so that's x is equal to 2, x is equal to 4. I'm going to just write it in an ordered pair so you get used to seeing it. Because if you're taking the EOC, you might have to write it that way, or you might see it that way. So again, x-intercepts, y is always 0, so it's just the same thing as saying 2, 0, or 4, comma 0. And then the last thing is your vertex. Again, we're going down. Starts to stop there before it goes back up, so we know that's our turning point, which is our vertex. So let's go ahead and put that in. Been showing you this, so I'll stay with that theme. Go up, that's a negative, or I'm sorry, that's a 3. And right here is -1, so we know we have 3, -1. Remember, your x always goes here, and your y always goes there. It's our vertex. All right, now you guys are good to go. You'll have a practice sheet. Make sure you do that. Should be able to finish it. This stuff is actually pretty quick, and you don't have that many problems. So if you need help, go back and rewind this and see some examples, and that should help you. Or ask Ms. Lodahl. Alrighty.